Our product is a Rover companion, programmed to mirror a user as they move around a given space. We wanted to create a versatile product that was easy to interact with and could also be modified to be implemented in a variety of different situations. There are two main components of our project: the controller, which is held by the user, and the Rover itself. By holding the controller and moving around with it, the user can easily control the movements of the car. If the user turns, the car will as well. If the user walks a certain distance away from the car will follow. The Rover and controller each have an XBee and a magnetometer, which is essentially a digital compass. The former communicates via UART, the latter via I2C. The controller transmits its magnetometer data to the Rover through the XBee. By calculating and comparing the two approximate headings, we can change the heading of the car to match the controller. To implement the follow component, we placed a BC118 Bluetooth receiver on our car, which communicates via UART, and an Estimote iBeacon on our controller. The beacon sends Bluetooth advertisements which the receiver picks up. By measuring their signal strength, we can interpret a distance. If this is larger than expected, the car automatically moves forward until the distance reaches an appropriate value. The car and the controller each carry a battery. The car with a 9.6 volt battery, the controller with a 7.2 volt battery. We originally used a 12 volt battery on the car, but we discovered that this caused overheating from the 5 volt voltage regulator in H-bridge, which essentially disabled the motors. To fix this, we reduced the voltage of the car battery and also added as many heat sinks as would fit in our setup in order to better disperse the heat and prevent thermal shutdown. In order to make the components easier to work with, we decided to solder the major devices on the Rover and controller. This allowed us to not have to worry about loose connections between our communicating devices and gave us one convenient board to work with instead of 4 or 5 loose items. We faced our fair share of obstacles while working on this product, both with software and hardware. Fortunately, we were able to solve many of our problems before our project demonstration. In the beginning, we found that our receiver was not able to get consistent data from our Estimote beacon because the signal strength fluctuated wildly due to the beacon's sensitivity. To fix this, we had to perform a lot of smoothing to the data in order to get more consistent measurements, though this did create a lag in the reaction time of our Rover. Afterwards, we noticed that our magnetometers seemed to work, but one of them was not working properly on its x-axis. We took care of this easily by implementing a quick hack and orienting our devices on the y and z axes. We still had problems with correctly receiving the magnetometer data. However, we were able to send begin and stop ASCII characters with each data packet, letting us find the information we needed more easily. A significant hardware problem we ran into was the lack of usable UART pins for communication with our devices. We needed 2 UART connections, both non-negotiable, running at the same time, but could not find an easy way to run them parallel to each other. Luckily, we found that we were able to simply add another MSS UART connection and only had to configure some extra pins. Lastly, when trying to get the car to actually follow the user, we found that the set speed of the car was too fast for it to stop in time, even if it got close to the beacon. Because of this, we decided to make the car move in short movements with a pause in between, thus allowing for it to easily stop when it reached its destination. We feel that our project matched well with what we intended it to be. It is still a rough cut of what we hope will be the final product. We had to make certain assumptions, like assuming the user will always move forward and not backward or sidestep, and had some loose connections that caused the communications within the project to run less smoothly. We hope that this project can be expanded on several ways in the future, since it is a very versatile implementation. Some features we'd like to see added are path tracking, motion or lights detection, and an all-terrain vehicle used to make this product very usable in the present day. We aim to create a product that would surpass a simple single use and be very integrable and easy to add on to, and we think we definitely met our goal with MirrorMe.